Some problems based on length of an arc, area of a sector, angle subtended by an arc at the center. A wheel makes 360 revolutions in a minute. Through how many radians does it turn in 1 second? Let's go by unitary method. 360 revolutions in a minute. This minute is time, not the subdivision of degrees. 360 revolutions in 60 seconds. 1 minute means 60 seconds time. So, 6 revolutions in 1 second time. 360 divided by 60. In 1 second, 6 revolutions. So, each revolution is 2 pi radians. So, 6 revolutions will be 6 into 2 pi radians in 1 second time. That is 12 pi radians in 1 second time. Circumference of a circle of radius r is 2 pi r units. That means if you draw a radius and consider an arc which is subtending an angle 360 degrees at the center, this complete arc, its length, arc length from here till here back, when the angle subtended is full 360 degree, the length of the arc is 2 pi r units. So, when the angle subtended is 1 degree, then the arc length will be 2 pi r upon 360 units. So, the angle subtended when the angle is theta degree will be 2 pi r by 360 into theta. This is the formula to find the arc length when angle is measured in degree measure. Now, once more let us consider the arc length is 2 pi r itself, but this time the unit for the angle used is radian measure. So when the angle subtended is 2 pi radian, 2 pi radian is same as 360 degree. When the angle subtended is 2 pi radian, the arc length is complete circumference. It is 2 pi r units. So when the angle subtended is 1 radian, the arc length will be 2 pi r upon 2 pi. 2 pi. For 2 pi radian, 2 pi r units. For 1 radian, it is going to be r units when you simplify. So when the angle subtended is theta radians, then the arc length is r into theta. This is also obtained by unitary method. When the angle at the center is 2 pi radian, 2 pi r units. 1 radian, 2 pi r upon 2 pi radian units. Theta radian, this equal to r, that r into theta. R theta units is the arc length. So this formula we use when the theta is in radian. We use this formula when theta is in degree measure. Both of these formula used for arc length of a circle. Remember, in this formula theta should be in degree measure. In this formula theta is in radian measure. How can we find the area of a sector? Here, if the central angle is complete 360 degree, that covers the full circle. So the sector is in fact complete circle. So area of the sector will be area of the circle itself, which is pi r square. When the angle subtended is 360 degree, then the area of sector is pi r square units. Now if the angle subtended is just 1 degree, when angle subtended is 1 degree, then the area will be 1 upon 360 of this pi r square. Pi r square upon 360 square unit. That is for 1 degree. So for theta degree, that sector, if this sector has theta degree subtended at the angle at the center, the area will be pi r square by 360 into theta. Here you notice the theta must be measured in degree measure. Now, as we have one more new unit for angle, that is the radian measure. How will we have the area of the sector in case the angle is measured in radian? We again go by unitary method. One full rotation is now 2 pi radians. So corresponding to 2 pi radians, that is one full rotation, the area is pi r square units. That is the complete circle. But when the angle is 1 radian, from 2 pi radian make it 1 radian. So the area pi r square will be divided again by 2 pi. So the area will be pi r square upon 2 pi, which is equal to r by 2. Simplifying it, you get r square by 2. So the area of the sector when the angle subtended is 1 degree at the center, 1 radian at the center, this is the area. So for theta radian, if the sector is subtending theta radian at the center, then the area will be this area into theta, where this theta must be measured in radian. So we have two formulae, one for finding the area of the sector when the theta is in degree measure, and the other for finding the area of the sector when the angle theta is measured in radian measure. Find the degree measure of the angle subtended at the center of a circle of radius 100 cm by an arc of length equal to 22 cm, taking the value of pi approximately as 22 by 7. Here there is a circle whose radius is given to be 100 cm. And we are told there is an arc which has the length 22 cm. Now we need to find the degree measure of the angle subtended by the arc at the center. Let us make it subtend at the center. Yes, this angle theta is what we want to find out. We will directly use the formula, the arc length formula. The arc length is 2 pi r by 360 into theta when the angle subtended is measured in degree. So the equation is the arc length is equal to 2 pi r by 360 into theta, where we substitute all the values that we know. Arc length is 22, and this equation simplifying by taking the value of pi as 22 by 7, calculate the value of theta. Next, in a circle of diameter 40 cm, length of chord is 20 cm. Find the length of the minor arc. Here the circle has diameter 40 cm. It is same. Diameter 40 cm. And there is a chord whose length is 20 cm. Let me take this chord as 20 cm. Now, we need to find out the arc length. This arc length is what I want to find out. So, let me make the angle subtended by this chord at the center. This chord subtends an angle 60 degree because it is given that the diameter is 40 cm. So the radius from the center till this point, this will be 20 centimeter. And this is also a radius, that is also 20 centimeter. And we are told the chord is also 20 centimeter long. So this triangle is an equilateral triangle. All the three sides 20, 20, 20. So the angle at the center, the subtended angle will be 60 degree. Now, if we need to find the length of this arc, we will use again the same formula. But this time we know the value of theta, and arc length we will find out. So arc length is equal to, here is the same formula. Now we use theta is equal to 60 degree and calculate. Taking pi is equal to 22 by 7, complete the calculation and you get the length of the arc. If in two circles, arcs of same length subtended angle 60 degree and 75 degree at the center, find the ratio of the radii. We are given two circles. Now, it seems there are two arcs of same length. In these circles, the length of the arc given is equal. Now, this arc will subtend certain angle at the center. This arc will subtend another angle at the center. We need to find the ratio of the radii. We are told angle, the arc length equal. The angle subtended, one of them is 60 degree, one of them is 75 degree. Here it is. Here, let us take the radius of the first circle to be R1 and second one to be R2. So, from the first one we can say, using the formula, arc length formula, the one which we used just now, arc length is equal to 2 pi r by 360 into theta. Here, L is equal to 2 pi r by 360 into 60 degree for this one, and here this L is equal to 2 pi r by 360 into 75. This R is radius 2 and this R is radius 1. Now we are told these two arc lengths are equal. So we may equate these two expressions as the arc length are equal. Now from this equation, let us find the ratio of R1 and R2. There are a lot of common factors. So after deleting the common factors, 2 pi by 360 from both sides, we have R1 into 60 equal to R2 into 75. Therefore, R1 upon R2 is equal to 75 upon 60. That is equal to 5 upon 4 dividing by 15. So we have R1 is to R2 is equal to 5 is to 4. That is the ratio of the radii.